project. Ah, ha.
Ano na naman yan? Ang gulo naman yan. Ano yan?
Ha? Ito ay tinatawag na 7447 BCD decoder. Ha? With 7 segment LED. Meron ditong mga pyesa. Oh. Ha? Meron tayo sa input na deep switch, DIP, dual inline package. And then may mga resistor at may mga LED. Resistor, LED. Yan yung para sa binary digit. 4 bits siya, 4 na LED. Oh. 'Di ba? At meron ding IC. Yun, may IC diyan, yun. Yan yung 7447 binary coded decimal IC. And then connected is the 7 segment LED display. Oh, may mga resistor, may transistor, at may power LED. Yan ay common anode. Yung ating 7 segment LED.
Oh, ano namang mangyayari dyan?
Ba? So dito sa project natin, yung input, which is the binary digit, 4 bit, usually in the digital electronics, i-convert niya sa decimal at i-output niya sa 7 segment LED. So yung 4 bit, 4 binary digit, 4 binary numbers is going to be converted to decimal with the use of 7 segment LED. Tingnan natin. Connect na natin sa supply, 5 volts. Para makita mo. Yan o. Eto na, subukan na natin. So sa unang initial state, milaw na yung 7 segment, 0. So ang count niya from 0 to 9. And then power LED, and then magi-input na tayo ng bit. So for the binary bit, bit number 1, least significant bit. Ayun o. Diba? So, isang LED equivalent to 1. Decimal 1. How about number 2? O, dito yan. Pangalawang sa deep switch. You know. For the second LED, 2. And then, for 3, combination of 2 switches, 1 and 2. Oh, 3. 2 LED. Nagre-represent ng binary digit. 4 bit siya, di ba? 4, number 4. Binary digit 4. For the third LED, 4. Sa decimal, 4. 5. Combination of 2 switches, 1 and 3 sa LED. Then 5. Kung 6, 6 6, 7, 7, and then 8, 8. Di ba? 8, 9, 9. So mapapansin mo pa, bago-bago yung ilaw ng LED kasi siya yung binary digit. Oh. And then pwede ring 10. Pwedeng 10. Kaya lang, sa 10, broken character. Itong ating BCD counter, capable siyang mag-count from 0 to 15. Kaya lang yung 10 to 15, broken character na. Katulad niyan. Yan ay 10, 11, 12, 13, 14, and 15. So pag 15, off. Balik natin sa initial. Zero. This is now the schematic diagram of our project. So we have here the power LED with a supply of 5 volts for the circuit. And then for the deep switch, we're using the switch, slide switch, that is the deep switch. And then we have this 7447 BCD decoder, binary digit decoder, and a display LED, common anode. And what's the use of this transistor? The use of this transistor with an LED each transistor, it serves as an indicator for the binary digit. We're going to input a binary digit. And we also have this pin out for 7 segment LED. So we have the pin out 1, 2, 3, 4, 5 from left to right, and then 6, 7, 8, 9, 10. Segment A for the LED segment. Segment B, C, D, E, F, G. So if you're going to light segment A, when you're testing the segment A is pin number 7. So pin number 7, segment A, pin number 7. Segment B, you're going to light this LED, pin number 6. So and so on. Common is 8 and 3. Since this is common anode, pin number 8 is connected to the supply, also pin number 3. And pin number 5, that is dot for the pin number 5. Dot. There's a dot for this display. In our circuit, we have this 4 resistor. They are grounded via pin number 7, 1, 2, and 6 of the 7447. What's the use of this resistor? in order to produce a logic level low, or we're pulling it down to the ground, because we are going to convert a binary digit into decimal. What is the binary digit? Binary digit in computer, in our case or in our project, we're 4-bit, 4 binary digit represented by each LED. So 4 initial state, since the resistor is grounded, we are referring to this as low level, 0 0 0 0. So since we are 4-bit, initial state of the circuit for this binary digit or bit, short for binary digit, is they are all grounded, 0 0 0 0. So the equivalent of that in our display, because this is a decoder, it converts a binary digit into decimal. So in decimal, this is 1. I mean 0 0, because initial state where we have seen that the display is 0. Okay, and what happened to the transistor? Since the switch is open, there is no current to flow into the base of each transistor. So there's no triggering current for the base of each transistor. That's why LED turns off. That's why at the initial state, if we have this 0 0 0 binary digit, 4-bit binary number, this is the way how the computer read the number 1, number 0, 0 0 0. They are all open. So what if we're going to close the switch 1? So it becomes high. Pin number 7, high, becomes 1. So in the binary digit, it becomes 0 0 0 1. And this first digit, this is called least significant bit. That is in the datacom subject in school. And the most significant bit is this fourth digit. Least significant bit now is 1. It means LED 1 turns on. Why? Because when you close the switch, it will inject a current to the pin number 7 of this IC and will display what is the decimal equivalent of the 0001 binary digit, equal to 1. As you have seen here, it becomes 1. The display of the LED becomes 1. Okay, now what if we're going to make, let us jump to the other number. What if we're going to make a number 5 for the display? Since we are manipulating the switch, for the switch, in binary, switch 1 equivalent to 1. Okay? Switch 2 equivalent to 2. Switch 3, 4. And switch 4, 8. So here, this is 1, 2, 4, 8. So if we're going to manipulate the switch, and we need a number 5 for the decimal number, so we need 4 plus 1. So this 1 should be on, and 2 should be off, and 4 should be 1, and 8 should be 0. So for binary digit 0101, it is the way how to that is the way how the computer communicate to the outside world. 0101 is equivalent to decimal number 5. Okay? Why? Because 1, least significant bit 1. Since this third place or third digit is 4, 1 plus 4, 5. So if you need the number 6 for this display, just slide the switch, slide or turn on the switch 4 and 2, making it number 6 in the display. And what happened to the transistor? When you close the switch, since we are closing the switch of number 5, number 5, least significant bit 1. So we're injecting a current here. This is 1. And then what happened to the transistor? It will turn on. So that's why the LED turns on. Once this is switch on, okay, the current flows into the collector to emitter, and then switch turning on this LED. So when there's a current here, it will turn on this LED. So as you can see, every time that there's an LED that turns on, it represents 1. And also, this one, no. This third transistor, because we're closing the switch for the third transistor. Okay? Injecting a current to the base of the transistor. Switching this transistor. Number 3. And then, current now flows from 5 volts to the collector. Turning on this LED D3. So the LED now is turning on from transistor 1, this one, and this one for this number 5 display. So that is the function of the module. Since this is common cathode, when you say common, I mean common anode. This is a common anode display. When you inject a current to the, for example, pin number 7, the current flows from pin number 3 or pin number 8. They are both connected, 3 and 8. And it will flow into the LED. For example, this segment, it will flow into this segment and then to the resistor and then to the 7447. Because this 7447 is collector, open collector output. And this is common anode. If you're going to draw that the drawing is like this. The anode is the common, which you're going to connect to the source. Common for each LED, for each segment. And then the resistor is now the one that varies. Okay? The anode is common and the cathode is not common. So it is depends on the switching in which what LED you're going to turn on. So for this IC, we need to connect the 3, 4, 5 pins to the positive. This is only used for cascading for another display, cascading another display. So if we're not going to use that, we're going to connect it to the supply. And pin number 8 ground, pin number 16 the power of the 447. We need resistor for each LED segment in order not to damage this display. Okay, and this is the power LED, so that we know that the circuit is on. So that's the purpose of this module, to convert this binary digit, or in short bit, into a decimal, because we cannot read this binary number. Only the computer read this. This is the way how the computer communicate with the human. And we need to convert that to decimal. So we need this decoder. And the way the binary digit produce is by manually switching this dip switch. Manually turning on off these switches. So we can produce a number for each depends on the switching. Okay? So that is how this module works. This is 7447 BCD binary coded decimal. It means this IC is capable of converting a binary digit into decimal with the use of LED display. So when you inject a current here, and the current flows from 5 volts to the resistor and inside the IC of this 447. When you inject a current here.